Okay, today, proofs with parallelograms. Proofs. Let's use all those properties still. All right, let's use all those properties. I will let you know, hopefully to make your life a little bit easier, the one property we probably won't ever use in a proof is this one right here. Consecutive angles are supplementary. It's still a property, but we usually don't use it in a proof at all. So we're looking at these four are the main ones. All right, these four are the main ones. So I want to start you off with just a basic proof, very basic. Look at what the givens say. These two are parallelograms. So all those properties I just had up on the board apply. Those two are parallelograms. Get me WX and ZY congruent. First question for you guys. Can this just be a two-step proof and I could say, hey, WX, ZY, they're already congruent. They're opposite sides in a parallelogram. What do you think? Opposite sides in a parallelogram are congruent. Should be two steps and done. What do you think? No, why not? WX and ZY are in two different parallelograms. Can't pull that business. Cannot pull that business. But what somebody's going to tell me now is WX is congruent to another side, but not ZY. All right, so that's where I want to start this proof is, yeah, WX is congruent to another segment, but it's not ZY yet. What segment is it? Start this off right. Stellan, what's it? What is it? VT. There we go. WX is congruent to VT. Reason, we wrote this a couple times on Friday. Notice that what I'm starting out with, parallelogram, implies, and then you guys tell me the property that was just used. All right, what property was just used to say it was congruent to VT? Ooh, here we go, Drew.
Opposite side.
You got it. You tell me it's a parallelogram, then you tell me what property you just used. Nice and easy. Good so far. All right, let's hop over to ZY, the other segment in the proof statement. All right, anybody see anything that might be congruent to ZY in this proof because it's parallelograms? ZY and what do you got for me here? Ooh, two, Bailey. VT. Oh, that's interesting. VT. Parallelogram implies. What property was just used there, Simon? To say ZY congruent to VT, what property did we just use?
Same opposite side equal.
Yep, opposite sides congruent. If anybody wants to ask, but maybe you think you might be wrong. Yes, I could have put this step in step two. I could have just combined them because it's got the same reason. But I want you to see both steps separately. And here's, guys, it's going to be difficult, these proofs. And I know some of you don't want to hear that because you're not hot on the proofs. The reason these proofs are going to be a little bit more difficult, what unit are we in? This is unit number what? 6, which means we have 6 units of theorems we could use. That's why these proofs are going to get tougher. And we're going to end this not with the parallelogram proof, but with something we've used in unit 2. All right, that's why you may start seeing these proofs become a little bit tougher for a few of you. How am I going to combine these two to get WX equal to ZY? Because it's not a parallelogram property. What are we using to combine them here, Micaiah? WX equals VT, ZY equals VT. So they equal each other because of?
Substitution.
Okay, substitution there. You can thank your boy there. All right, but hey, look, guys, that's why it's going to be tougher. You got to grind. All right, you got to grind. Or you could say, you know what? Screw it. I'm not doing the homework. Right? And then good luck on the test and quizzes. All right? I'm not good at proofs. Then why are you still here? Why are you still here? All right, we've given you a quarter and a half now to get out of here. All right, you're going to have to grind 6 units of theorems. All right, 6 units of theorems you're going to have to go through. WX congruent to ZY, substitution. Questions there? That's just a little intro. That's just a little sniff. That's all that is here. Ready to move on. All right, let's do it. Oh, look what's back. What are we asked to prove in this? Don't write a darn thing. What are we asked to prove? Oh, 2 triangles congruent. That sounds familiar, right? All right, before we do anything, let's roll. There's only 5 ways we could do this proof. 5 ways. Let's go. I'm not going to take time doing the numbers here and put people on the spot again. What do we got? HL. Yep. SAS. Side angle side. Side side side. Angle side angle. If the side's not in between, angle angle side. All right. These are our only options. Okay. We're not. These aren't disappearing. So we got to prove these two triangles on the outside are congruent by one of those 5 methods. We do have a new symbol in here, right? That symbol is for parallelogram. If you want to use it, I'm okay with it. But again, it's only for parallelogram. We're going to go over a lot more quadrilaterals. That symbol that we're using in the givens, you can only use it for parallelogram. All right. But if you want to use it, go ahead. I'm going to keep it to the old 11ogram I've been writing. All right. DF is congruent to EB. And that's really about it. And ABCD is the parallelogram. Please look where ABCD is. It's the thing. It's the quadrilateral in the middle. That's the parallelogram, not the big one around. All right. The one in the middle, ABCD, is the parallelogram. Right. I want to focus on the triangles being congruent. So again, we need 3 pairs of sides or angles. Oh, so sorry, above average math kids, I gave you none. I have given you none. You are on the hook for all 3 pairs of sides or angles and where they come from. I'm going to tell you the first pair should be darn easy if you know your parallelogram properties. All right. Can anybody find a pair of sides or angles that are going to be congruent in those 2 triangles? Because you know your parallelogram properties, and ABCD is a parallelogram. All right. Give me a pair of sides or angles in those triangles you know are automatically congruent. Here we go. Finley. There we go. DA and CB. Boom. Those have to be congruent because that's a parallelogram. DA is congruent to CB. Parallelogram implies. Tell me what property was just used there. What property did we just use, Vinny?
Opposite side repeater.
Good. We're building. We're getting there. Ready? Watch. I can put an S next to that because that's a side. 2 more to go. 2 more sides or angles to go. That one was the easiest one. Next one's going to be a little bit more difficult, but I still have a lot of faith that you should be able to find it. They gave me DF and EB for a reason. Use it. How can I start playing with DF and EB to maybe to get another side or angle? Probably not an angle. Let's be real. How else can I use those givens? We ready to roll? I want to use DF and EB. Brendan, anything?
Oh, you can subtract.
That's all you need to tell me. Subtraction. Everyone see? Well, he says subtraction. What are we subtracting? The givens from the other pair of opposite sides, which I'm going to put in the same step as number 2. So we're going to subtract the givens with AB congruent to DC, the other pair of opposite sides. Because everyone see when you subtract, you get a pair of sides in the triangle. Good, Brendan. Good. Good man over there. So let's subtract them. EB minus AB equals DF minus DC. Subtraction. Yep. I just wrote down subtraction, so we know our next step's automatically a what step here, Bryson? Substitution. That gets me a second pair of sides in EA and FC. Everybody catch up before we find the third pair. Okay, I honestly expect everyone to get to this point. All right, you should be able to find those two pairs of sides on your own, no issues. That's how I feel we are, where we are, and where we should be in the year. The third pair is going to be a bear, though. It's going to be a beast. And that is what you're going to find out as you do these proofs is the first two pair to prove the triangle's congruent are going to come very quick. Third pair, you're going to have to dig deep. Third pair, you're going to have to dig deep. Try to make your life a little easier, though. I still have the 5 reasons to prove triangles congruent up there. You should be able to eliminate 3 of them based on what we have right now. It's definitely not going to be HL because that's got to be in right triangles, and I don't see any right angles there. Done. I have 2 sides, right? 2 sides. Good. That requires only 1, and that requires only 1. So it's got to be down to these 2. Make your life a little easier. It's got to be down to those 2. So either I'm going to try to prove the third pair congruent or the angles in between. It's got to be one or the other. Okay, so at least you have some type of direction on where to go, even if you're really just stuck. Here's where we're going. Let's go back to ABCD as a parallelogram. What do you know about the opposite angles? They're congruent. That's a property. All right, don't write anything down. I'm just going to show you where we're going. So those are equal. Can I count those as angles in the triangle, though? No, they're not in the darn triangle. How can I get them in the triangle, though? This is something again, 6 units of theorems now. It's a lot. Dylan, you going to explain something, brother?
Use their supplements, just the supplements of congruent angles.
Everyone look right next to them. Agreed that these are linear pairs. They are supplementary. And these are supplementary. Supplements of congruent angles are congruent. That's where we're going with this. It's going to take us 3 steps, but that's where we're going. We're going to say the opposite angles are equal. The angles are supplementary, so their supplements are equal. The ones right next to them are always equal. That's where we're going to get that angle. All right, first step, got to tell me the opposite angles are equal. So angle, what are we looking at here? DAB, congruent to the opposite angle DCB. Parallelogram implies opposite angles congruent. Before you tell me the angles next to them are equal, you have to tell me which angles are supplementary. So now in step 6, write down the 2 pairs of angles that are supplementary. So angle DAB with angle DAB and DAE are supplementary. And then jot down the other pair up top. Angle DCB and FCB are supplementary. Why? Why are they supplementary? What are they? It's just vocab now, Bailey. They're linear pairs, right? Linear pairs are supplementary. Then you can tell me the supplements. The ones in the triangles are now equal. Angle DAE congruent to angle FCB. And that theorem was supplements of congruent angles are congruent. And then all I need from somebody is to finish off the proof and let me know what method lets us know these 2 triangles are indeed congruent. Drew, why are they congruent?
Side angle side.
Side angle side. Good job. And there we go. First two pair should come easy. I say should. I know we're at different levels in here, but the first two pair of sides or angles should come pretty easy. Third pair, though, got to grind. Okay, got to dig deep and search for them. And that is exactly what's going to happen in the next proof. Please don't write anything down. I want to talk. You can write all. I'm going to give you and your group time to try to complete this one on your own. Just look at the proof statement. SE congruent to QF. Okay, so I see SE, I see QF. I don't know if we're in this mode yet, some of us. Those two segments are not going to be congruent unless you prove what congruent first. What do I need congruent first before SE and QF get congruent? The triangles that contain them. Because at the end, what am I going to say at the end for SE and QF? This is what type of proof? CPCTC. So you and your group right there. Let's just do it together. There's only one pair that contains SE and QF, right? Only one pair of triangles. SEP and QFR. I'd like you and your group right now to get after it. See if you can prove them congruent. My bet, you'll be able to find 2 out of 3 sides or angles. The third pair you're going to struggle with, and that's where I'll swoop in and help us out as a full class. But if you and your group can find those pair, that'd be great. If not, no shame. But you definitely should find 2 pair. No excuses there. You definitely should find 2 pairs of angles or sides on your own right now. And then I'll swoop in and help you with the third pair. So go ahead if you want to talk it over where they are, write them out. And then we'll talk about where the heck that third pair is.
And 90 degrees here.
I'm going to wait too. All right, I'm going to wait till everyone's got those two down. There's no excuse here why we shouldn't have two sides or angles down. Whether it be a parallelogram property or your Gibbons. You should have two angles or sides written down. I get nervous if we can't find those two sides or angles in this one. I get not finding the third pair. I get that. I'll help you with that. Definitely should find two pairs here. Where's this coming from? We don't know SF and EQ are equal, so we can't subtract. Here we go. Now. We didn't even use any of the givens. The fact that they're perpendicular lines. Didn't even use them. Okay, you can't write this because SF and QE are. You need two pairs of equal quantities. We don't have anything. We don't have anything. So 3 and 4 are totally out of the picture. Use your givens. Okay, here we go. We should have had the following at least. PS congruent to QR, parallelogram implies opposite sides congruent. And we should have used our givens to say angle PES and angle QFR are right angles, and then saying they're congruent. Use your givens. They're there for you to use, not to overlook. So those are the two you should have automatically had. Any questions there? Okay, so where's the third pair come in now, right? Because I have a pair of sides and I have a pair of angles. I definitely need one more pair. All right, so let's talk. Friday, I gave you a heads up on this, and I don't care if it's in an algebra question or a proof. What is SQ called again? When I connect two non-consecutive vertices here, what is SQ in this diagram? That's a diagonal. If a diagonal is drawn in, you will have alternate interior angles. Let me say that again. If you have a diagonal drawn in, there will always be alternate interior angles in a parallelogram. Where are they now? If I say they're there, where are they? Angle PSE and angle FQR. Take a look. Those are the alternate interior angles. Now, whoa. Hopefully we're not writing they're congruent in the next step. They're not congruent yet. What type of lines do you need to be alternate interior angles to be congruent? The lines need to be what first? Parallel. You need to tell me the lines are parallel before telling me their alternate interior angles are congruent. Now, I understand this part. You get confused as far as what lines do I need to prove parallel? Is it this pair or the other pair? You know my answer? Write both down. Write both. It's correct, right? Both pair are parallel, so write them both down. All right? It's an extra little step, but I'm not going to mark it off. So it should be PS parallel to QR. But if you don't see that, just to be on the safe side, write them both down. Go ahead. PQ parallel to SR. Parallelogram implies opposite sides parallel. Then you can tell me, but again, I need the parallel lines first. Then you can tell me the alternate interior angles. If a diagonal is drawn in, look for alternate interior. FQR. I got one more issue before we end this. What's your reason here? Because you can't write parallelogram implies. What am I going to write implies, though? Parallel lines. That's why you told me they were parallel the step before. Parallel lines imply alternate interior angles. Congruent. And the final thing I'm going to ask from somebody is, why are the triangles congruent now? What is the method being used? All right, what method am I using to say the triangles are congruent at the end of this proof? Cormac? Angle, angle, side. The side's not in between, and then make sure you finish the proof by saying CPCTC. And that is where I'm going to end it today. I'm not going to do the last proof with you. It's something that's a little bit too above what we need to do in here, so we're not going to do that proof. So that means I'm going to eliminate one of the proofs in the homework that's similar to it. You are not responsible for number 2 tonight on the assignment. You are not responsible for number 2 on the assignment tonight. So one less problem proof for you to do. Just real quickly, because I saw this be a common mistake last period when I let the kids in first period start the assignment. For number 1, in the givens, it says CA congruent to CG. That's not the left and the right side of the triangle. Make sure you mark the correct sides congruent. All right, a lot of students last period were doing the right and the left side of the triangle. That's not what it is, right? Look where CA and CG are. Those are the 2 sides that are congruent. All right, and if those 2 sides are congruent, what else must be? The angles across from them. Good start. All right, go ahead, get moving.